pathway. An inspector checks the melting status of the glass ingredients, as well as the flow of gas to fire the furnace. This furnace is burning 24 hours a day, 7 days a week, and is monitored constantly. The hot liquid glass now flows between two rollers, one of them engraved. The rollers imprint designs onto the glass and squeeze it to its final thickness. The glass rapidly solidifies, fixing the pattern in the ribbon of glass. It then travels through a 60-meter-long temperature control zone. The glass ribbon is exposed to flames to relieve stresses caused by the manufacturing process. This is called annealing. The glass slowly cools as it leaves the zone. This seals in strength and durability, so it can now be cut cleanly without fracturing. This cutter scores the glass lengthways, but it doesn't cut it all the way through. The scored line maps out the desired width of the glass. Another cutter moves to and fro to create horizontal score lines. These score lines establish the length of the pattern glass panels. Then a roller pops up and breaks the glass along the horizontal score lines. The sides of the glass now collide with small wheels, known as bonkers, which snap the glass along the lateral score lines. The waste glass falls down a chute to rollers that burst it to bits. These bits are called cullet, and they'll be recycled into new glass. A worker now backlights glass panels and examines their finish for flaws. This solar glass panel has a matte finish, compared to the small sample of standard clear glass. It's less reflective, allowing more of the sun's energy to be captured. Minerals high in iron produce greenish glass that's light absorbent. For solar glass, they go easy on the iron to produce white glass that transmits light. A carrier with suction cups stacks the glass for shipping. Now all that's left is a spot of window shopping. Road cases, or flight cases, are designed for the job of transporting sensitive equipment like musical instruments and audio systems. These wheeled trunks are tough on the outside, with cushy foam on the inside. With flight cases, the gear arrives intact and ready to rock and roll. Behind every superstar, there is plenty of this custom luggage. Each case is designed for a particular piece of equipment, like an audio mixing console. The case is being made to measure. They load the dimensions of the audio console into a computer, and then design a virtual case around it, using three-dimensional software. Once a customer approves the computer blueprint, they're ready to build. Workers roll adhesive onto thick birch plywood. They coat the entire sheet. The plywood is now ready to receive a thermoplastic outer skin. They align the thermoplastic with the adhesive-coated plywood and lower it into place. They feed the thermoplastic and plywood layers to rollers that squeeze out any bubbles for an airtight bond. Then the heat from this hot press activates the adhesive and cures it for an even better bond to the plywood. The result is a laminated thermoplastic plywood sheet. Next, a computer-guided router carves through the laminated sheet, following the design drawn up in cyberspace. This produces the exterior panels, each one precisely sized for the audio console case. The router also cuts out holes for latches and other fittings. A worker pieces together the panels to form the basic carcass of the case. He tacks them together temporarily with a staple gun. He'll join them permanently with an extruded aluminium trim. He prepares the aluminium edging by punching rivet holes. He also cuts notches for bending it around corners. He's now ready to install the aluminium trim. He can actually bend the corners by hand for a perfect fit. The edging gives the case a tailored look, and once riveted to the panels, it will hold it together. He drills through the holes in the trim to make corresponding holes in the laminated plywood. He inserts rivets into the holes. These rivets have mandrels attached to them. He drives those mandrels through the rivets, causing them to expand around the drilled holes, and secure the trim to the trunk. With the job done, the mandrel breaks off and is disposed of. With the case now held together by the metal trim, he rivets the latch to it. and then it's onto the inner framework. The plywood parts also have to be cut with computerized precision, designed to hold that audio console. He reinforces a piece called a cheek with a thick block of wood. The cheek is one of two that will cradle the audio console. He bulks up the wide end with plywood copies of the cheek's contoured profile, gluing them and nailing them to the main part so this reinforcement job holds. He spray paints the cheek substructure black, giving it a durable, textured finish. He fits the cheek in the case, one on each side, and then bolts them into position. Another worker hot glues blocks of foam, each specifically cut to fit together like pieces of a puzzle, as he installs them in the case. All this padding will cushion the impact of any bumps on the road, or backstage jostling. He even covers the top of a plywood drawer made for a keyboard. They slide the audio mixing console into the case to try it for size. From start to finish, it's taken about 3 hours to make this flight case. It should last for as long as the audio equipment does, but it all depends on how rough it gets on the road. Testing. 1, 2, 1, 2. Coming up, stop frame animation. Lights, camera, action. See you after the break. Many animated film and TV shows use stop frame animation. The characters are three-dimensional puppets with movable facial and body parts. The animator moves the puppet ever so slightly for each frame of film or video. When you view the frames back at regular speed, the puppet appears to be moving. Bringing a make-believe world to life through stop frame animation takes a large and talented team, which includes writers, directors, animators, set and prop makers, camera crews, and of course, puppet makers, who create, maintain, and repair the puppets. To see how stop frame animation works, let's rewind this scene, which stars Timmy and features a red balloon. The director takes the writer's script and breaks down each scene of the episode into a series of shots. This shooting script then goes to the storyboard artist, who draws each shot of the scene on a digital storyboard tablet. For each scene, the director prepares a set plan, detailing the background elements, the puppet placement, and the camera angles. The storyboard artist sends his drawings to the editor, who works with the director to edit them into an animatic, a still drawing version of the episode. Actors, meanwhile, have recorded the dialogue in a sound studio. Now the editor cuts that dialogue into the animatic. The visuals in this soundtrack must be perfectly synchronized, because the animators will use this as a frame-by-frame guide for moving the puppets' bodies and lips. The show's animators refer to a large schedule board to see which scenes they've been assigned to animate. A printout of the animatic shows all the shots at a glance. In the art department, construction of the episode's costumes and props is well underway. To make a few red balloons, for example, the prop makers sculpt one out of modelling material and use it to produce a hard silicon mould. Then they pour quick-setting resin into the mould cavity. After the resin has hardened overnight, they open up the mould and extract the casting. They drill a hole in the bottom. Dab some glue inside. Then insert a small triangular peg, also made of quick-setting resin. This forms the tight bottom end of the balloon. Now a coat of grey primer. Then once it dries, red paint. When the paint dries, they drill another tiny hole at the base of the balloon and insert a strand of flexible copper wire wrapped in cotton thread. This is the balloon string. The team of of animators shoot several scenes concurrently, so in the puppet department, model makers produce more than one puppet for each character. Certain body parts, such as hands and wings, are made of silicon, with a wire skeleton within. After forming the wire to shape and applying a base coat of silicon, the puppet maker lays it in a two-part mold, then fills both cavities with silicon. She closes the mold, clamps it tightly shut, and leaves the silicon to set overnight. The flexible wire skeleton at the core enables the animator to manipulate that part of the puppet. Timmy's torso is a polyurethane foam core dressed in a wool coat. It has channels for interchangeable wires, which support his head and arms. His head is made of resin, his arms silicon over a wire skeleton. Timmy and his friends' faces can express a wide range of emotions thanks to interchangeable mouths, flexible ears, and blinks, an assortment of exchangeable eyelids. These convey expressions from wide-eyed to cockeyed. These facial features attach either magnetically or with tacky wax, a flexible, quick-release glue. The puppet maintenance team packs each character and its parts in a travel box, then sends it to the animator on the studio floor. During shooting, the animator changes the facial expressions as required. Their work requires great technical skill. The animators, under the director's guidance, bring the puppets to life. The puppet's legs must be sturdy enough to support the weight of the upper body, so the leg skeleton is made of metal rods connected with a ball and socket joint. The feet are metal plates, hinged to allow movement. Just like the flexible wire skeletons, this metal skeleton also goes into a mold to be encased in silicon. The arms attach with square-section brass tubes, so they can be easily changed with an Allen key. Certain puppet movements require rigging. A rig is a device which enables animators to raise the puppet off the floor of the set to perform jumping and skipping. The animator can incrementally lift or lower the rig to any height and lock it there.